Hello everyone. We're in this lecture we're going to see how to create tables with SQLite and Python, and specifically I'm going to create them with the Qt library instead of the SQLite library. So before we get started with this is an entity relationship diagram, also known as an ERD. Now, you can read about ERDs in the textbook and also online, but the entity relationship diagram describes how the tables in the database are related. And so before we create this database, let's get an idea of the structure, because that's what this diagram is telling us. So this diagram is saying that we're going to have two tables in the database. One's called task and the other is called projects. The tables have information about the same thing grouped together. So all the projects would be in this projects table. All the tasks would be in the task table. Now, for each project that you create, you would have one or more tasks. I hope that makes sense. When we create a project, let's say the project is mow the grass. Well, there's several tasks that are associated with mowing the grass. One might be that you need to check the fuel in the lawnmower, check the oil, make sure that all the hoses are picked up. You see how many tasks I've come up with? That all those tasks would be related to the project to mow the yard. So you may have 4 things that you do to accomplish that project to mow the yard. So we could have another project that was let's say change the wipers on the car, and the first task associated with that might be to purchase new wiper blades, and then the second task might be remove the old wipers, and the third task might be install the wipers. So you see how we had multiple tasks for that project to change the wiper blades on the car. So this diagram shows us that each project would have a associated ID with it. The ID has an asterisk to the left, which means it's the primary key. That means that ID uniquely identifies the project. No two projects could have the same ID. There's also a column in there for the name of the project. Every project that we create would have a name. The project would have a begin date and an end date. So you see how those things are all related to a project. Now, we just got done describing that every project could have more than one or more tasks associated with it. And this line here on the entity relationship diagram is actually telling us that, because it's saying that we always will have at least one project ID or project for a given project. But over here, This crow's foot, as they call it, means that there's many over here on this side. So one project to potentially many tasks. One to many. This little O right here says that it's an optional relationship, meaning that we could create a project and we may not have figured out the task for it yet. So it's fine for us to be able to create a project and not have any task. That's what that O signifies. But if we create a task, it must have a project. That's what these lines over here mean. It must have a project. It's mandatory. We could not create a task without having a project first. So when we go to create this database, we have to keep that in mind, because this relationship right here describes the order that we would create these tables in. Now think about it. If we have to have a project for a task, then that means that we really should create our projects table first and then create our task table. Same way if we go to enter in the project and the task associated with the project. When we got ready to actually put stuff in the database, we would have to populate the project first before we could create a task. So this line right here with the vertical lines and the crow's foot is actually getting created right here where it says foreign key project ID references projects ID. That's what's creating this relationship. Okay, so this page here in the lecture in Blackboard has the code to do this with SQLite. That's fine. That's all good to create this with SQLite. And you can see the full source code right here where it says import the SQLite3 library. The downside to doing it this way is that if we wanted to use an Access database, we would have a different library here for Microsoft Access, and all of our code would be different. If we wanted to use an Oracle database, this library would be different and our code would be different to Oracle. It would be specific to Oracle. If we were using Access, the code would be specific to the Access library, and the statements would be specific to the Access library. So I'm going to show you a different way, a way that's not here. Feel free to use this way with SQLite if you want to, with the SQLite library. However, just know that everything that you do is specific to that, and if you ever decided that you wanted to use a different database, or your boss decided it for you and said, hey, we're switching all of our databases over to SQL Server, well, this code would be different. So if you want to save yourself all that work of having to redo everything, if the database changes, then it's time for PyQt5 to rescue us from that issue. So I'm going to show you how to create these projects and tables using Qt5. And if you use Qt5 to do this, then if your database changes, you pretty much change one line of code instead of everything. So let's get started with that. On your C drive somewhere, you'll need to go ahead and create a folder and name it DB. So I have a VirtualBox session running here, and all I did is went out here to my downloads folder, and I right-clicked and came down and said new and folder. And when I did that, I typed in DB, and that created a DB folder in my downloads. So this is where we'll create our code for creating this database. So we'll place our code in the DB folder in your downloads. So I'm going to go ahead and do it on Linux because the font displays a little bit better. But here's my downloads folder, and there's DB, and you can see the folder's empty right now. So I'll go ahead and start Tawny, and we'll create this code to make this database. And so the first thing, of course, is we need to, in case there's an error, we want to be able to pop a message up and tell somebody something happened. So in this DB folder, why don't we go ahead and get that Qt message box code and put it out there, so I can get that code right here where it says Qt message box. I'm in the folder with this lecture to create tables. Okay, so just going to right click that and save the link and save it to my DB folder. And so now I've got that code out there. So there it is. And if you want to see what's inside it, you can see it's got all this stuff in there. You don't have to understand what it's doing, but it's there. And since we're in using Qt5 and everything, you probably would understand a lot of what's going on in here. This is a constructor. This is a class. And so anyway, enough about that. Let's go back to Tawny and we'll create this program. So let's see if we can type from Qt underscore message box import star. That brings the message box in. Now we need some imports for Qt. This import that I'm fixing to do gets us the SQL library for Qt5. That right there gets it for us. And let's go ahead and import some specific stuff. QSql database and QSql query. Those are the two items that we use a lot. And then if we wanted to catch some errors, we can. This line really, we may use it, we may not. From QSqlite or from SQLite, import error, capital E. Okay, so let's go ahead and create our connection. Now the nice thing about breaking this up into functions to do this work for us is we can use this function in another program because we're always creating a connection to a database. So this same function could be used over and over as long as we're connecting to the same database. And actually, we can write the function such that it takes the database file in as a parameter. And so we really could reuse this function for pretty much anything. Create connection. And we'll pass in the DB file name. Okay? So next we'll DB equals QSql database. Okay. Add database. Okay. And this is the one line that you would have to change if you wanted to use this code with another database, because right here, this is where we're telling PyQt5 that we want to use an SQLite database. There's another one of these constants right here for or identifiers for SQL Server. There's one for access and so on. So that's the one piece of code that we would change. db.set database name. This is the file name out there on the flash drive or on the disk. And here we're going to trap for the error. This is saying if we didn't get the database open, then we're going to show a message box. Okay, that's the title for our message box. And then we can have a string in here. And this is just going to tell the person that's running the program what happened. And we can go ahead and put a skip down to a new line. And keep going with this. We'll give them a couple extra lines there. Click cancel to exit. Okay, so that's the end of our message box that we're going to pop up, and then we can say return, and we'll return false if we didn't get a connection. And if this did get a connection, then it will return the database. So we can do this. So just keep in mind, this code right here is only going to run if we didn't get a connection, because that's what it's saying right here. If we skip over this, then we end up down here, and that gets returned to our program. Okay, so next we can write a function to create a table. And So def create table. And this is a function that'll take some SQL in and use that SQL to create a table. So we're writing a generic function that you could use to create any table. This is our parameter that's coming in. Okay. And then here we're going to do a try and an except. We're going to try to create a QSql query. And then we're going to take this query object and run the SQL that came in right here from that parameter. So query.exec underscore, and then we'll pass the SQL. Okay, so we tried that. Lots of things can go wrong. Lots of things can go wrong when you're working with a database. So if we get here, then some error has happened, and we can print that error out and let the person know what that error was, rather than just having them see a trace back and that's the end of it. So this is going to actually print the error message that we're catching right here. Okay, so if that worked, then that's all of our create table SQL that we have to worry about. Now let's create our main program that will call these functions. And this is where most of the code is actually going to be, that's specific to what we're trying to do. So let's go ahead and tell Python what our database name is, and we should probably save this in case the power were to go off or something. So file, save as. I'm going to go to my downloads folder, which for you on Windows, we put that in your downloads folder as well. So going to my downloads folder and looking for my database folder right here, and we'll save this as create DB tables. Create DB tables with qt.py. Okay, so we've got that saved. Let's go ahead and create our variable that we're going to pass to this create connection when we call it. So database equals, and I'm putting an R in front of it. Now, when you make a string with an R, a little R outside of the double quotes, that means it's what Python calls a raw string. And if you recall, when we put a backslash in a string with Python, normally Python thinks you want to escape something. And so that makes it hard when you're wanting to do something like this. If we wanted to tell, put an exact path in here, we would, on Windows, we'd be doing something like this. C:users backslash whatever your username is, and backslash, and maybe downloads backslash DB backslash, and then whatever our database name was getting called, which Python SQLite DB is what I think this example that I'm doing wanted us to name it. So You see how all the backslashes in here? You wouldn't be able to do this without doing this on Windows, because a backslash is considered an escape character. But if you put that little R to make it a raw string in front, then you can get away with doing this. So that's why you'll see most folks using that R in front of it. Now, I'm not going to put a path in there, but I wanted to at least talk to you about why you'll see folks doing that. Okay, so here we're going to create the SQL code, which we'll just save it in a string variable. So SQL create projects table equals. And this is going to be a lot of a string, so it's going to be long and it's going to be a multi-line string. So did you see the 3 quotes that I put there? That's saying it's a multi-line string. So we'll do that because we want to be able to wrap this around so that we can keep track of what we're doing. So create table. Now, normally when I'm doing SQL, I'll go ahead and put the SQL keywords, the things that mean something special to the SQL language. I'll go ahead and put them in uppercase so that I know those are SQL keywords. If not exist. So what this is saying is don't destroy the database if it's already out there. It's saying check, and if the database doesn't exist, then go ahead and run this code. If it does exist, then you'll get an error. And you might want to go save your database first if you had something in it so that you don't lose that data. So this is kind of just playing it safe. Okay. Now, when we're doing this stuff, this create table projects, you notice how I have this parenthesis here, and I have another parenthesis there. Okay. With SQL, most of the time you put a semicolon to terminate it. So I think SQLite and Qt will let us get by without that, but some systems won't. So I'm going to go ahead and put it there so you can see the way you may have to do it, because some databases are real touchy. Okay, so if you recall from this diagram right here, we have an ID column, a name column, a begin date, and an end date column. So that's what we're writing right now. Is we're saying create a table named projects, and these are the columns that it needs to have. And ID is going to be an integer column. Okay, that's the data type, and it's the primary key. Okay, very important. That says that this column must be unique, and it uniquely identifies every row in the database. Next, we'll do the name column. You notice I put a comma. If you forget that comma or leave it out, this won't work. Name is going to be a text column. That's as close as we can get in SQLite to a string. And we're saying we're making an additional rule here. Not null means that you can't leave name empty. Every project will have to have a name. It won't let you put it in there without a name. The next column is begin date, and it's a text column. We have to save dates in SQLite as just text, and then convert that text to dates in Python. So that's why SQLite doesn't have a good date column name or type. Some databases do. So if you were using a database that supported dates, then you could use something else. End date is going to be text. You notice I didn't put a comma after the last column name. So these are the columns right here that are going to be created in this table for projects right here. Okay, so now that we've got that, we need to create the SQL to create our task table. SQL create task table equals, and we're going to have another long string here. So I've got those 3 quotes going on. Create table if not exist task. Okay. And let's go ahead and do the columns in here in this table. ID, integer, primary key. The next one is name, and it's text. It's a string, and we can't leave the task name. We don't want the folks using our database to leave the task name empty, so we're making it have that extra rule. Priority, integer. Okay. Status, integer. We're getting these rules. You would probably be told the rules, like every project has to have a status, whether it's started or in process or what. And project ID is our foreign key that are our column that references a foreign key. Okay. Project ID integer, not null, meaning every task has to have a project ID. Can't leave the begin date, and we can't leave the end date empty for our task. This is our rule to make coming up to make our relationship. The foreign key is project ID, and it references the projects table, projects up here, and every project has an ID, so projects ID. And that's the end of our SQL to make the task table. So let's go ahead and put the code in here to call our functions to get a connection and so on. So create a database connection. This is where we're going to call that function. Connection equals create connection, and we'll pass database to it. What is database again? It's the file name of our database out there. That's coming from right here. Create connection Create connection is the function up here that we wrote to create that connection to the database. So here's where we're calling that function. Right here, we're calling it. And it's going to return to us a connection. And remember, if it returns nothing or false, then we're going to create those tables. So create tables if connection is not none. Create projects table is my little comment. Okay. Create table SQL create projects table. Now what are we doing here? This is the function that we wrote up above to create a table, right? If we go look, right here it is. Create table. Okay. We're passing this string right here to create the projects table. So this is what's actually getting passed to it. Okay. So that's going to create our projects table. Task table is next. We could copy this right here and paste it and just change this to say create task table right here. See where that's coming from? Okay, once we've done that, we need to close our connection. Database connection. Okay, closed it. We'll have an else here. The else is something happened. Remember, if we didn't get a connection, then we'll come down here and we'll print a message. Okay, something happened and we couldn't create our connection. Lastly, we've written the main function here. We've written this create table function. We've written this create connection function. We need to call our main function. If, remember this code. This is allowing us to import this into another program. Okay, so this is where we'll call main. So that's our whole program right here. Here's our main function. Here's where it's getting called. It only calls this if we're not being imported. If we're being imported by another program, then all we do is these functions get created and this line here does not run. Okay, so alright, so we've got that. We'll save it. Now if you look out here, right now we've just got our program and our message box. So if we did everything right here, and remember I told you one comma can mess this up. One misspelled word in your SQL can mess stuff up. One misspelled keyword. Okay? If we forget our parenthesis, and I think I may have forgotten one. Let's see. Right here, create table task. Okay? Yep, I forgot one parenthesis right here. whoops, parenthesis, and a semicolon. Okay, this parenthesis right here matches that one. Okay, so if you left this out, it wouldn't work. Okay, this one, let's just check our work here. We've got this parenthesis. We've got this one closing it. Okay, we've got comma, comma, comma. The last one doesn't have a comma. Here we've got a comma, 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 no comma. Okay, all this looks pretty good. So going to try to run it and see. It's rare that you get one of these that works right the first time, just because there's so much that's going on when you're working with a database. You've got connections and you've got all this other stuff. So we've got our imports up here. Let's try it. Okay, and it says invalid syntax, so I must have left a colon out here. Let's see, if not, DB open. Right here, I left a colon out. I told you. Okay, did you see how I clicked on an underline and it took me up there to fix it? So let's try it again now. Okay, we did not get an error. So let's see if we've got something out there. And look, we have a database. Now, I provided you with the DB browser utility. I think it's on the announcement. Let's see. DB browser right here. You see it? Okay, this is what we call a portable app. You notice it says portable right there. Okay, that means you don't have to install it. If you extract this zip file, you'll have a folder for DB browser. You can find DB browser in there and run it. Let me show you what I'm talking about. Right here. Okay, here's my downloads folder on Windows. Okay, here's where I extracted that. Okay, and you'll notice in here there are two different executables. Okay, there's DB browser for SQLite. There's DB browser for SQL Cipher. SQLite, and I think I mentioned this in another lecture, but SQLite doesn't have any security built into the database. None. There's no passwords, there's no users. So if you're going to put this database out there on a web server or somewhere where it's unprotected, then you can create a encrypted database. And if you encrypted it, then you would use this DB browser to get to it. We didn't do any encryption, so if you just double click on this DB browser for SQLite, this is what will open up. Okay? And if you go to File and Open Database and go to our DB folder, there's our database that we created just now. You click on it and open it. You can see everything that's in that database. It's got two tables, okay? And you can see the SQL code for those tables. If you click this little arrow right here, you can see the column names that got created. Here's our task table. You can see the column names there, okay? If you click on projects and right click and click on modify table, you can actually see the SQL right here that we wrote in Python to create that table. Okay, You can see the column names and what the data types were of the column names. You see where it says PK? That's the primary key. Where it says NN, that's not null. Okay, so same way with our task table. Okay, modify. You can see we had several things that we said were not null there. You can see our relationship right here that we did. Okay, so if you had data in there, you click this Browse Data tab, you could click the various table, and you could see the data that was in the table. So that's DB Browser. It lets you just kind of see what's going on inside that table, okay, or inside that database. So what we've done here is we've done what they had here in this lecture that was specific to SQLite, except that we did it with Qt. And remember, Qt will work against any database. So most of the stuff moving forward that we do, I'm only going to show you code in Qt because I want you to be able to use the code, write the code once and use it lots of places. Okay? So that's the end of the lecture to create tables. I will put the code out there. These command line tools, if you like to run stuff from the command line, you can use them. I showed you how to use the graphical tool, the DB browser tool, which down here where at the bottom where they were showing running that SQLite utility from the command prompt and against the database, and then looking at the tables to see that the projects and the tasks were there. You saw we did that in a graphical way with DB Browser. Okay? And remember, DB Browser is that portable app. So that's the end of this lecture. Good luck creating tables. And you have two ways. One way here with just standard SQLite library, where they're down here in the full program where they're doing this to use SQLite library. And then the way that we did it with Qt, we used the PyQt5 QSql and the QSql database and QSql query. So there's where we created a QSql query. All right, good luck.